Now let's consider some of the implications for r squared by different values in our correlation table. So let's start here. If we have this is our correlation table from before, right? And the relationship between x1 and x2 is r12. Relationship between x1 and y is r1y. Relationship between x2 and y is r2y, with 1s on the diagonal. And then we have our equation for r squared. R squared y12 equals r squared y1 plus r squared y2 minus 2 ry1 ry2 r12 all over 1 minus r squared 12. And again, we're not worried about the proof for that. Just accept it. There's places you can look it up if you really want to know. But look, here's the big I believe. Just press the I believe button. And that's the way it is. So, because it's not necessary for our further discussion. Now let's talk about what happens with different values of our relationships, our correlations among these variables. In the first case, let's say everything is completely independent. x1 and x2 are unrelated to each other, which means that their correlation is 0. And in this case as well, x2 and y unrelated to each other. And also x1 and y unrelated to each other, right? So none of our three variables are related to each other at all. We could diagram this so that this is the variance in y, this is the variance in x1, this is the variance in x2, and none of the variance in either of our predictor variables helps explain any of the variance in our outcome variable. They are all completely independent from each other. Now, if we plug in 0, this reduces to 0 plus 0 minus 2 times 0 times 0 times 0 all over 1 minus 0, which is equal to 0 over 1. And as we would expect in this case, r squared is equal to 0. R squared equals 0 means there is no explanatory value in our model. That neither x1 nor x2 nor the combination of the two explains any of the variance in y.